Welcome to this explainer. Today, we're unpacking the mechanics of something called prism resonance. Specifically, we're going to explore how this totally fascinating tool solves a very real and honestly very frustrating problem in standard RAG systems, that is, retrieval augmented generation. We're talking about the huge issue of shifting operational context. Picture this. Production goes down. Every single second counts. You urgently ask your internal AI assistant for the database failover steps, and it confidently hands you a Q3 capacity planning doc from last year. Yikes, right? I mean, when you're relying on an AI that literally cannot tell the difference between a quiet Tuesday afternoon and a full-blown critical emergency, you're basically looking at a recipe for disaster. So why exactly does it do this? Well, that brings us to Section 1, the limits of standard RAG. You see, standard RAG systems, they're incredible for stable knowledge. But here's the catch. They treat every single piece of text, every embedding, as a fixed point in space. The system basically just asks one question. What text is mathematically closest to this query? Now, that's perfectly fine for a quiet Tuesday when you're just browsing FAQs. But it fails completely, absolutely falls flat, during an active outage. Why? Because your query isn't asking what's relevant right now based on urgency. So as these databases grow, engineering teams run into massive limitations. We're talking about flat nearest neighbor scans that basically force you to bolt on these clumsy metadata filters just to make sense of things. Plus, there is absolutely no native way to gate which memories actually participate during a crisis. And then you end up with manual memory consolidation, major duplication risks from constantly syncing databases, and the real core issue, conflating what a document actually means with when it should matter. All of that just gets mashed into a single vector. This leads us right into Section 2, introducing Prism Resonance, which is a brilliant solution developed by Insight IT Solutions. Think of Prism Resonance as a dynamic sidecar brain for your AI. And the best part? It's a free, open-source memory layer. But here's the kicker. Instead of replacing your existing vector database, it just wraps right around it. So if you're using pgvector or Chroma, it uses read-only adapters to connect. It models text chunks as wave packets, and it never mutates your existing data. Your original source of truth stays perfectly intact and 100% trustworthy. Now, the core philosophy here is RAG memory that resonates, not just matches. And honestly, I love that phrasing because, matching is really just finding neighbors on a static list. But resonating? That means related chunks of information actually amplify together when they share the right context band, while all that irrelevant noise just naturally cancels out. It's actually a lot like how human memory behaves when we're under stress. Moving on to Section 3, the physics of memory. Let's look at the radio analogy. Okay, to understand how it actually achieves this resonance, we kind of need to demystify the underlying math here, which models data as wave packets. But don't worry, let's look at this through a really simple radio analogy. Imagine your frozen embedding. The actual semantic meaning of the document is the amplitude. Think of that as the song itself. The new element Prism Resonance introduces is the phase. And the phase acts as the specific frequency band, or the radio station, that you tune into based on your current operational context. So you keep the exact same song, but you're just changing the station based on what's happening. This clever dynamic builds a highly efficient two-level retrieval process. So when a query comes in, step 1 is the group layer. The system first finds the right neighborhood of memory using constructive interference, basically doing a coarse recall to pull all the relevant emergency data together. Then we hit step 2, the chunk layer. This is the fine recall, where it fine-tunes and ranks the specific chunks of text within that newly formed resonant group. Next up, Section 4, the 6 frequency bands. So Prism Resonance uses 6 distinct frequency bands. These are neutral at 0 degrees, normal at 60, alert at 120, emergency at 180, recovery at 240, and archive at 300. By assigning one of these frequency families when a document is initially saved, your query mathematically dictates exactly what surfaces. And guys, this is huge. It means an emergency query inherently and purely mathematically suppresses archive noise. The context gating is literally baked right into the math. You don't have to rely on those clumsy metadata filters we talked about earlier. Let's see this in action in Section 5, a tale of 2 outages. Imagine an engineering team facing a major failure. Without phase gating, someone types in a frantic query about an EU database failover. That triggers a flat search. The AI just sees the word database and pulls up, old migration blogs, which leads directly to AI hallucinations. Not helpful. But with Prism Resonance, setting the query phase to emergency instantly aligns the waves. It completely suppresses those irrelevant blogs and purely surfaces the critical runbook steps you need that very second. It's a total game changer. All right, Section 6, Clean Architecture and Consolidation. You know how standard vector databases require heavy manual reindexing as documents just keep piling up? Well, Prism Resonance solves this with a really cool biological approach. While the system runs, it utilizes a background 4-pass sleep cycle. It goes through decay, synaptic merge, group recompute, and finally, persist. It literally decays weak bindings and merges near duplicates. Basically, it biologically consolidates memory, which completely eliminates the need for those massive, resource-heavy, full reindexing jobs. And it gets even better. Because this is an entirely open-source tool, it runs its Wave engine on standard CPU servers using ONNX. There is absolutely no heavy, expensive PyTorch required here. So what does that mean for you? It means you get this incredibly advanced AI memory layer without paying a massive GPU hardware tax. It integrates cleanly, and it runs incredibly efficiently. So as you think about the future of your own AI retrieval systems, the ultimate question is no longer just, what text mathematically matches my query? The real question is, how can you ensure your AI always turns into the exact frequency of your current operational reality? By shifting your mindset from just matching to actually resonating, your AI finally understands the context of the moment. So what memories belong in resonance with your current moment? Thanks so much for joining me on this explainer, and I'll catch you next time.